or the modeling part. So I can just like give a brief summary of what we have done till now. So you start with just like framing the problem itself and defining the evaluation matrix. Then we have do some environment setup or define the libraries and the Python libraries that we will use and the main functions that we will use. Then we collected the data and take like a quick look at the data structure and the data features. Mhm. And then we created a test data and left it alone out so we can uh, test our model at the end of our project. Then we start in data exploration. We first visualizing the geographical data, the latitude and longitude, and we visualize it with other features such as the median house values and the population. And then we start to looking for the correlations in the data, especially with the target value that we are trying to model, which is the median house value. And we also done some plotting for the correlation with other features. Yeah, and then we start the data preparation, which start with data cleaning, and we found that we have missing values, so we have to fill it, and we saw some different options to fill the data. And we used this one, the simple computer from sklearn. And then we have to also handle the text data, so we will use one hot encoder from sklearn also. Then we created our own custom transformation. Uh, one was for the numerical data, which includes three transformation or three operations: a simple computer, the combined attribute, which adds the three more features that we will use, and also standardization. And then we also have done the same, but for the category feature, which include the one-hot encoding. Then we combine both of them and apply it to our data, which is a full pipeline. And now, like, just we can just this one line will summarize all what we have done before. So this one line will take the housing data itself and will do the for the numerical it will do three operations: standardization and imputer and adding three features. And for the categorical feature, it will do the one hot encoding. Now our data is ready for the modeling part. So we know that it's a regression problem. So we'll start with simple regression models such as a linear regression, and we can see like how the model will results on the training data, and we can after that select more models. So first we will call the linear regression from sklearn and train the data, fitting the data has housing prepared and housing labels. So this is our prepared data, and this is the label we are trying to model, which is the housing median price. So this is just like a sample of the predicted values. When we compare it with um, with the real or the ground truth value, we can see there is some difference in the values. And also we can calculate the root mean square error, which is defined here. So simply the root mean square is the ground truth minus the predicted value, averaged and taken, and we take the root for it. And the more the higher this value, the worst our model. So our goal is to make this value as small as possible, especially for the test, of course, and the validation set. Yeah, so we can see here that we have the RMSE is this number, which is quite high. This is like the difference between the expected value and the predicted value. So we might like try another maybe a stronger model to see how it will go. So we can like apply the decision tree regressor. Decision tree are very good models that can we are expecting that it will give like better results. So we'll just like make the same. We will fit the model and then calculate the root mean square. We can see now that it's zero on the training data. Um, this might like appear as a good thing, but actually this means that the model have overfitted the training data. So it will not like will not be able to deal with the test data after that, because it just like have learned all from the training data. So that's why we will have to use a cross validation, so we can like understand what the model have actually learned. Um, so we can use like cross validation as we mentioned in the theoretical part from this lecture. Yeah, also we can use the cross validation score from sklearn also. We will give it the tree regressor and the data we will use and the number of fold or the number of the key folds that we will use. And here we will calculate the root mean square. We can see now that the this is like the R mean square. It's higher, even higher than the linear regression models, which means that on the validation data, the decision tree was even worse than the linear regression. So we can like apply another model. Yeah, this was the linear regression. We can use the random forest regressor. Random forest is also a very strong one. Of course, we are just trying to go, like we are trying to train different model, but we can also achieve good results with the decision trees. But we'll have to tune the parameter and choose another parameter that are suitable with our model. But we're just like trying to go fast here and going through different models. We can also, like as mentioned, try the random forest regressor. Um, and also we will do the same. Now we can see that the root mean square have decreased a lot. Like it was in the range of 70 and 6,000. Now it's just 18,000. So now it's good. This was on the training data, and here it's on the validation data. It's 50,000, but it have somehow improved from the last two, the decision tree and the linear regression. Now we can just like start to change the parameters, so we can like find the best parameters that will give us the best results, especially on the validation data, not on the training data. There is two common methods: the grid search and the randomized search. The grid search is when you will just like define the parameters that the model will go through, and the model will go through each of them. So, for example, here we have the n estimator, which is the number of estimator in the random forest we are using. So we'll define three value for it, 3 and 10 and 30, and the maximum feature for each tree in the random forest. So we have like 3, and then we have here 4. So it will combine like all the available, or all the available possibilities, and will go through all of them and give us the best feature, the best combination, the best parameter combination after that. Yeah, here we have defined all the values we're trying to tune, the hyperparameter we are trying to tune, or we like to tune, and we will fit the model on the data and see which what are the best parameter. So now we can see that the best parameter are when the maximum feature are 8 and the number of estimator are 30, and we can yeah, here we will just like print all the iteration we have done with the different with the different parameters, or not the different, with the different values for each parameter. and here are the R mean square for each of them. So this one step, but usually we this is somehow requires that you have like sense what will be the best values. Another better method would be the randomized search, in which you just like define the like range for values, and it will go automatically and like find the best values or the best parameters values. So here we also do the same, but in different ways. So the estimator will find like the low will be like one, and the like for our range it will be from 1 to 200, and the maximum feature will be from 1 to 8, and the model will try to like um, find the best values between these. Like a good method is to combine both the randomized search and the grid search with each other. So you first do some randomized search, and after the model give you the best values, or the randomized search give you the best values, you can do some grid search around these best values, so you can like improve it more after that. So here also we can find like the best value is this one, where we have the maximum feature is 7, and the estimator is 180, and the root mean square is 49, which is the smallest one we got till now on the validation data. Yeah, here after we have find the best model, or the best model and the best parameters that we could use. Of course, this is somehow simplified in a real project. You will have to do like more fine tuning, and you can try more models and do fine tuning for each model and so on. Uh, yeah, now you can just like print the feature importance for each feature, so you can like maybe you can do some other iteration and remove the useless feature. So here we will just like print the importance of each feature, but in a descending way. So we can see that the median income have the highest importance, which as expected from the feature from the data exploration that we found that they are quite correlated with each other. Then inland, this is one of the one hot encoded categorical feature. This also is have important. um, we can see like the one which is not important is like maybe this two or this three. So if we have a lot of feature, we can just like remove them. But here we have just like small number of features, so we can just like keep them. But like if you have a lot of feature and you would like to remove some, so this might be like a good choice to remove. Yeah, now after we have like trained our model, we can uh, see how it will go on the test data. So we will just first we will have to apply the pipeline we have created, the cleaning and the preparation pipeline on the test data. So it will go through the same process as you remember, the filling the missing values, and standardization, and removing or handling the categorical values. Then we will calculate the root mean square on the predictions, and we can see here that now it's 47. Of course, the next step might be if you like to create a web app or a mobile app that use this model in real time, then you will take the model and deploy it on a live server after that. Yeah, this like is briefly like a life cycle of a data science project. Of course, every step can be like uh, every step here is somehow summarized, but in practical we will spend more time in each step. And of course, the data itself here is very simple data, but in a real project, the data will be very complex, and you'll have to spend more time in the cleaning part and in the data exploration, and also with you might need to do some feature selection and feature reduction, and the modeling part will be more complex, and you will have to do um, more fine tuning and more model selection and so on. But yeah, this is just like uh, a simplified um, case study which show most of the life cycle we have talked in the first part. I don't know if you have any questions. What
Thank you very much, Youssef. It was very clear, and I hope that participant can see things have a global overview of a data science project now. So
Okay,
please, if
thank
you
you.
have any questions, actually, Youssef, I have one question, or maybe two.
Yeah,
So
sure.
yes, my first question is about one hot encoder. So actually, I can see that it is about attributing two values, 0 and 1. And then we are or we have maybe 4 or 5 classes. So it may give the same value for different classes. So do you think it is not causing some confusion for the model? I mean, for example, it can give one feature for the inland house, and then for maybe a very far house from the ocean. So, and then the price is not the same. So it gave the same feature for different prices. Do you think that it may affect negatively affect the model, or it has no problem?
Yeah, so actually it does not give the same value for each. Like here, for example, uh, it just give one for one of the five. Like here we have the value itself was for example it was might be the inland here, for example. So here it will just take this one. So each feature will be like somehow independent from the other, and the model after that can like
Okay. Mhm.
yeah. So just one of them will take
Differentiate.
one, and yeah, and the other will take zero. So the model will deal with each one as as an independent feature. And as we can see like here, it actually gave like four of them was less important, and just one was very important, which was the inland. So we can see that the model have understand that they are different, and some of them are important, or some of them are not important
Great.
for the
So I can see.
regression part.
Yeah. Yes. Yeah. I can see it now. Thank you. Thank you very much. For my second question, actually, I was, we have Suhila, yes. So we have Youssef with us, and he will share, inshallah, the notebook. Okay. So my second question is about evaluation metrics. So you mentioned that it can be chosen based on the data set, whether it is a balanced data set or unbalanced data set. Is there any other factors to know how to choose the right evaluation metrics?
Um, yeah, so like also it depends on the data. So for example, if the data is especially like in the regression part, if the data has outliers, but you need to keep these outliers, so you might need to have a certain evaluation metrics that are not affected by outliers. Like for example, here we use the root mean square error, but this is affected by outliers. So if we when we have done the data expression, if we found that we have outliers, and these outliers are part of the data and they are right, they are not they should not be removed. So we can use like the mean absolute error because they are not affected by outliers. So this is another point that we can choose the evaluation matrix on. Another one, if you are trying to compare our progress with the previous work, so we can also so we can have like the same baseline we are comparing with, so we can choose the evaluation matrix based on this also.
Okay. Mhm. Thank you. Thank you very much. So